Hello, welcome to Marsh Mathematics, and in this video we're going to be looking at how the cast method is used in trigonometry. Now, first of all, we're going to be looking at the unit circle and realizing that the graph actually comes from a point moving around in a circle of radius 1. Okay, and as it does, it generates the graph. Okay, the graph is generated by a point moving around a circle. So in this first quadrant, sine, cos and tan are all positive. Okay, they're all positive and they're all calculated using these ratios. Okay, and you should be familiar with that. But what's important in this section here is to realize when it gets to the third quadrant, for example, y and x are both negative. Okay, so this is the angle that we want, theta. This is not the angle that's used to calculate sine, cos and tan. It's the angle that's made with the x-axis. So alpha is equal to 180 minus theta. So this is the angle that's used to, because remember, we need a right angle triangle to work out sine, cos and tan. We do obtuse angles, okay, or angles greater than 180 degrees. We have to form a right angle. So it's the angle that theta makes with the x-axis, the acute angle, and this is angles called alpha. Alright, and if you notice there that sine is minus y over 1, so that's why it's there. Okay, and that is in the third quadrant. Now all the angles are calculated in this way. Okay, now this relates to cast, you see. So if we come back down here, we'll see that as this is the circle again, as there's a point moving round in this direction, you can see in the different quadrants why sine, cos and tan are actually the signs that they are. Now you don't have to remember all of this. This is just to show you where cast comes from. Really, cast, it's the method that you need to remember. So you can see that they're all positive in the first quadrant, x, y. Okay, all the ratios. But in the second quadrant, you notice because x is negative, that the only one that's positive is sine, because it's y over 1. And in the third quadrant, x and y are both negative. So the only one that's positive is tan, because that's minus divided by a minus. And in the fourth quadrant, okay, the only one that's positive is cosine, because that's x over 1. Okay, and that is where we get the letters cast from. Okay, because it is where sine, cos and tan are positive. They're all positive in the first quadrant, but sine in the second, tan in the third, and cosine in the fourth. And this is where we'd get our cast diagram. Okay, now as I said, we don't, when we calculate values of sine, cos and tan for angles that are more than 90 degrees, we don't use that angle to calculate them. We use the angle it makes with the x-axis, and this is this angle theta. Okay, so using the graph method, you don't need to worry about that. You just use the graph. Okay, but the reason cast is so, for me, is a superior method of doing it, is that we don't have to draw a graph. We can just do a simple cast diagram, and it's very easy to calculate the values that we need, you see. Okay, so let's have a look at a quick example. Sine theta is minus 0.5 within this range. So we're not interested in the positive and the negative sign, because cast sorts that out for us. Okay, because cast is all about sorting out what your positive and negative values are. So what we do, we work out alpha, the angle that it's going to make with the x-axis, and that's going to be 30 degrees. So we ignore the sine and work out alpha. Alpha is not the principal value, don't get it confused with that, okay? And that's 30 degrees. So we draw a quick diagram like this. So that's the angle that theta is going to make with the x-axis. So because it's negative, okay, and because it's in this range, negative, well, where is sine negative? Well, sine is negative in this quadrant and this quadrant, so it must be this angle, 180 plus 30, or this angle, 360 minus 30, and that's how quick you can do it. And I think that is quicker than the graph. Okay, that is quicker than the graph method. Okay, let's have a look at another one. We've got cosine theta minus 0.5. We were in this range, okay, because it's the range that we need to focus on as well. So okay, we don't worry about the negative. We find out what alpha is. Alpha is between 0 and 90 degrees, so we don't bother with the negative value, and it's 60 degrees. We draw our cast diagram. Alpha is the angle it makes with the x-axis. So then we look at the sine, and it's negative. So what quadrant must it be in? Well, it's cosine. Cosine is negative in these two quadrants. So the angle is either this one, which is going to be 120 degrees, or this one, which is this one, which, because it's got to be between 0 and 180, and then we've got to go backwards because of the range, okay, so it's going to be minus 120. So that's a bit scruffy, that, but I hope you understand that. Alright, so that is how quick we do it, and that's why I think cast sometimes is better. Now with tan, we can say, well, tan theta is minus 1, okay, remember, we're not bothered about the sine, we just find out what alpha is, which is tan to the minus 1 of 1, which is 45 degrees. Now this is our range, so we've got 40. We draw a quick sketch of the diagram, cast, okay, then we say, oh well, it's a negative, so when's tan negative, or negative in this quadrant and this quadrant, so theta must either be this angle, which is 180 minus 45, or this angle, which is 360 minus 45. Now that's how quick you can do it using cast. I hope that's useful for you. Okay, but also watch my other video on the graphical method. You might prefer that. Okay.